All right, today we're cracking open something really cool, Tulu3. This is a brand new approach from the Allen Institute for AI, and it's all about giving us a clear, step-by-step recipe for what's usually a super mysterious process, fine-tuning large language models.
So, have you ever tried to fine-tune an LLM? If you have, you definitely know this feeling. It's kind of like that famous how to draw an owl meme, right? You get step 1, draw 2 circles, and then step 2 is just draw the rest of the owl. There's this massive, unexplained gap in the middle, and it is just so frustrating. And look, this isn't some abstract theoretical problem. This is real. We found this comment from a user online that just hits the nail on the head. They said, "I've spent a week optimizing hyperparameters, but never seem to obtain satisfactory results." I mean, you can just feel the frustration there. It shows that even for people who know what they're doing, the whole process can feel like a total guessing game.
And that really gets to the core of the issue. The whole process of turning a raw, base model into a genuinely helpful assistant, it's usually a complete black box. You know, even with models that call themselves open, you almost never get the full story. The exact data, the code, the hyperparameters, it's all hidden. And that makes it pretty much impossible to reproduce their work.
So that is the black box problem that Tulu3 is designed to blow wide open. And what's important to get here is that it's not just another model. It's a complete, open recipe for success that anyone can follow. Okay, so what exactly is Tulu3? The best way to think about it is like a detailed cookbook, but for LLMs. It gives you a step-by-step methodology that takes all the guesswork, all the vibes-based tuning, and replaces it with a clear scientific procedure that you can actually replicate.
And listen, when they say fully open source, they are not kidding around. This isn't just, here are the model weights, have fun. No, they're releasing the entire playbook. We're talking all the data sets, the training code, the evaluation code, heck, even the scripts to set up the infrastructure. This is a level of transparency we just don't see very often.
All right, so let's get into the good stuff. Let's actually look inside this recipe and see how it all works. The whole pipeline is broken down into 3 main stages.
First up, you have instruction fine-tuning, or SFT. Then you move on to preference fine-tuning with DPO. And you finish it all off with reasoning fine-tuning using PPO. Let's go through each one of these. So, Stage 1, supervised fine-tuning. The goal here is simple, but absolutely crucial. You have to change the model's entire personality. See, a base model, fresh out of pre-training, is really just a superpowered sentence completer. It predicts the next word. SFT is what teaches it to stop just completing and start assisting, to actually understand and follow your instructions.
And how does it do that? Well, it actually uses the same basic trick as pre-training, next token prediction. But the key difference is that now it's supervised. You feed the model tons of high-quality examples, an instruction paired with a perfect response, and it learns to mimic that pattern, predicting the next word again and again until it can generate those great responses on its own. Okay, so now our model can follow instructions. That's a huge step. But the next goal is to make its answers not just obedient, but good. You know, aligned with what a human would actually find helpful. And that's where preference fine-tuning comes into play. The recipe here calls for an algorithm called Direct Preference Optimization, or DPO. It's a pretty clever system. You give the model a prompt, but then you show it 2 different answers. One is the chosen response, the one humans like better. The other is the rejected response. The model's job is to figure out why one is better than the other and learn to give the good one a much higher probability. Now, here's a really interesting detail. Where do these chosen and rejected answers come from? Well, they can come from an off-policy source, like a big, powerful external model. Or they can be on-policy, which means the model we're training actually generates its own responses, and we judge those. Tulu3 does something smart. It uses a mix of both, which makes the training a lot more robust.
All right, on to the final stage. This is where we really sharpen the model's mind. The focus shifts to pure reasoning. We're talking about tasks that have a single, provably correct answer. Think math problems, coding challenges, logic puzzles, that kind of thing. To do this, the recipe uses a reinforcement learning method called PPO, and it's really straightforward. The model tries to solve a problem, and if it gets the answer right, it gets a reward, a score of 1. If it's wrong, it gets a 0. That's it. This super direct black and white feedback is amazing for reinforcing the correct reasoning pathways in the model. So that's the 3-stage recipe: SFT, DPO, PPO. Sounds great, right? But just like any great recipe, it's totally useless if you don't have the right ingredients. And for LLMs, the most important ingredient, by far, is data. Lots and lots of high-quality data. And I mean, we are talking about a massive scale here. To do this right, you need something in the ballpark of 1 million data samples. 1 million! Public datasets just don't have that kind of volume, so you're pretty much forced to generate your own synthetic data to fill the gap.
But here's the catch. Generating 1 million unique instructions is way harder than it sounds. If you just go to a big model and say, give me prompts, it'll do great for a while, but eventually it just runs out of ideas. It starts repeating itself, giving you slight variations of the same thing. That problem has a name. It's called mode collapse.
So the team behind Tulu3 came up with a really brilliant solution for this. Instead of just asking for 1 million prompts, they added a step. First, they asked the model to generate hundreds of thousands of different personas. Then, they go to each of those unique personas and ask them to generate a few prompts.
And the result? It's incredible. You get this huge diversity of prompts. You get stuff from the perspective of a moving company driver or a chemical kinetics researcher and hundreds of thousands of other totally unique points of view. This creates an incredibly rich and varied dataset, and it completely sidesteps that mode collapse problem.
So the big question is, does it work? Does this very structured, recipe-based approach actually beat the old way of just fine-tuning based on vibes? Well, let's look at the data, because the results really do speak for themselves.
What you're seeing here is a really clear trend. Each one of those stages we talked about provides a clear, measurable boost in performance. The score just climbs steadily up, from the raw base model to the SFT version and all the way to the final Tulu3 model. It's exactly what you want to see.
So how does it stack up against the competition? Well, it's right up there, competitive with other big open-source models from around the same time. Now, is it beating the top-tier proprietary models? Not yet, but this totally open approach is a huge step in closing that gap.
You know, by open sourcing the entire cookbook, not just showing us the finished meal, the Allen Institute for AI has done something way more important than just releasing another good model. They've given the whole community a clear, validated roadmap to follow. And that leaves us with a really exciting question. Now that the recipe is out there for everyone to see, who's going to be the next chef to cook up something truly amazing?